All right, good afternoon. It's good to see everybody. So our plan today, I want to go ahead and introduce you to a concept called multiplicity. So we're going to start the next lesson, 1.5. Once we're done with that, the remainder of the time, I'm going to have you work on the exit ticket, 1.2 and 1.3. So tomorrow we'll most likely pass back the exit ticket, talk about any questions, do a little more notes. Remember, Monday, that's when the assignment for 1.4 is due. And then on Tuesday, we'll have our 1.4 quiz. Okay, so any questions about anything coming up? Everybody make it okay here today? I would be willing to bet tomorrow we would have another late start day. I haven't made a decision yet, but I'm definitely thinking that it's going to freeze in the morning, but we will see. All right. Well, let's go ahead and get to it. All right, so zeros of a polynomial function. Okay, so given a polynomial function p of x, if p of a is equal to 0, then a is a 0 or root of p of x. So what that means is, graphically, the polynomial is going to cross the x-axis at that location. That's where it touches the x-axis. Now, if a is a real number, then if x equals a is a 0 of function p, then x minus a is a linear factor of p. And in fact, we're going to be using those linear factors to help us find the zeros and ultimately what we're going to refer to as the multiplicity. So let's see what that means. If a linear factor, x minus a, is repeated n times, the corresponding 0 of the polynomial has a multiplicity n. Typically, we know that the graph of a polynomial passes through the zeros of the graph. However, when a 0 has a multiplicity greater than 1, the graph's going to behave differently near the 0. Okay, so let's look at an example. Let's kind of put this together. They're giving me this function, y equals a negative 0.01 times x plus 4 times x plus 1 quantity cubed times x minus 3 quantity squared. So this is graphed to the right. And it says, notice the behavior around the zeros. Well, first let's go ahead and talk about how we got the zeros. You might remember from algebra, like for example, a quadratic. A really good way to determine where the parabola crosses the x-axis is to factor it and then use the zero product property. Okay, so that's exactly what we're going to do here. It says that the first 0 is negative 4, right? So I'm going to go ahead and take this binomial factor, x plus 4. I'm going to set it equal to 0. So that is where I'm getting my root from. So we have x equals negative 4. And then if I take x plus 1, set it equal to 0, x equals negative 1. And then x minus 3 equal to 0, x equals 3. So that's where I'm getting my roots from. If you take a look at the graph, here's the negative 4, here's the negative 1, and here's the 3. Okay. But something is happening at one of the roots. You'll notice the graph crosses at negative 4 and negative 1, but at 3, it just hits the axis and bounces back. What's different about 3 than the other two? Does anybody notice it? Say it. Not the fact that it's negative. That's good. That's a good idea, though. Look at the powers on the groups where those zeros came from. So x plus 4, there's no power, so we have to understand that's a 1. Okay, this one's a 3. This one's a 2. So is there a difference between them? It's even. Yes. Okay, so the multiplicity of a 0 is the degree of its factor. Okay. So we have x plus 1 cubed. That's why negative 1 has a multiplicity of 3. Whatever that degree is, that's going to be the multiplicity for that root. Because x minus 3 is squared, the root 3 has a multiplicity of 2. Now, we're not putting a multiplicity for negative 4 because it was just to the first power. So if it's just to the first, you don't have to write out the multiplicity. But for this first lesson, I'm going to go ahead and do it. So I'm going to go ahead and say multiplicity 1. Okay. But that's exactly right. At x equals 3, the multiplicity is 2. The graph of the polynomial is tangent to the x-axis. Remember, when we say tangent, we mean just one point of intersection. So if a root has an even multiplicity, it's not going to cross at the location. It's going to hit the axis and come back, whether it's above or below. If it's an odd multiplicity, it's going to cross like we normally believe it would. Okay? So any questions about that? Okay, well, let's try some examples. Okay, for each of the following, determine the degree of the polynomial. Remember, that was the one term that had the largest power. Okay, find all the real zeros and state the multiplicity for each zero. Okay, so we're going to go ahead and start with the zeros and the multiplicity. All right, now for A, this one's already been factored for us. We got a negative 2x cubed times x plus 1, and then times x minus 4 quantity squared. Okay, so I'm going to take each factored part, and I'm going to go ahead and set it equal to 0. So the first part, negative 2x cubed. If I set that equal to 0, okay, so divide through by negative 2, x cubed is equal to 0, take the cube root. So what's x? What cube will give me 0? 0, there we go. So there's my first root. So x equals 0. Now, immediately after that, we want to state the multiplicity. Okay, so what was the power on the term that this root came from? 3. So this has a multiplicity of 3. Okay. And then we're just going to go right down the line. Okay. The multiplicity is the degree of that root. Okay. Well, next we have x plus 1. So if I were to take x plus 1 and set it equal to 0, x plus 1 equals 0. Well, my next root would be x equals negative 1. Okay. And what's the power on this group? 1. So that's its multiplicity. Multiplicity 1. And remember, I'll state it several times. If it has a multiplicity of 1, you don't have to write that down. But I'm just going to go ahead and do it for this first lesson because it's our introduction. And then for the final group, we've got x minus 4. If I set that equal to 0, my final root would be a positive 4. With what multiplicity? 2. There we go. So if I were to go ahead and graph this polynomial, okay, it's going to come into contact with the x-axis 3 times at 0, negative 1, and 4. Okay, which of these would it not cross at? It would just hit the axis and bounce back. Why 4? Again, why is that different? There you go. If the multiplicity is even, it won't cross at that location. It'll just hit the axis. But at 0 and negative 1, it will go through the axis at those locations. So are there any questions about multiplicity? Is anybody not seeing how I got these numbers? Okay. Now, I still want to go ahead and figure out the degree. All right. Now, one thing you can do as like a backup, you can just multiply everything back together, but it's really not necessary. You're only looking for the one term that has the largest power. Okay, so look at each group individually, figure out what the largest power would be out of that particular factor. Let me show you what I mean. So for the first one here, well, that's just a monomial. See, I'm not interested in the negative 2, I just want to know the powers. So there's no way to expand this. So that one, the largest power it would give me is 3. Okay. For the x plus 1 in the middle, there's just a power of 1, so we're not expanding it. So I would only get an x out of here. But if I took x minus 4 and I expanded it, what kind of x would I get out of that? X squared. Now think about your exponent rules. If I were to multiply x cubed times x squared, what would my degree be? 6. This would be x to the 6th. So my degree is 6. Did anybody want me to multiply that out just to show you? Okay. Are there any questions? Okay, well, let's try another one of these. Let's try B. Now, this one looks like A, that it's factored, but it's only semi-factored. It's not completely factored. Does anybody notice what I'm referring to? There you go. The x squared minus 4, that's a difference of squares. Okay, so if it's not completely factored, I would encourage you to go ahead and simplify it completely. So this is going to be 3. The x squared minus 4, I'm going to get conjugates. So that's going to be an x plus 2, an x minus 2, and then we have the x minus 2 quantity to the 4th. Well, does anybody notice it? Could I rewrite this expression like this? See, it doesn't matter that the base is a binomial. Okay? We've got same bases that we're multiplying, so the exponent rule still applies. I took the power of 1 here, added it to the 4. That's why I got to the 5th power. Now it's completely factored and simplified. I can do what we did in part A. Question. Okay, so what would I do now? How am I going to find my roots? Set them equal to 0. Now, I don't have to worry about this 3 because there's no x connected to it. So basically, I can just ignore that. So for the other one here, x plus 2, if x plus 2 is equal to 0, well, my first root is x equals negative 2 with what multiplicity? 1. Multiplicity 1. And then for the other group, if x minus 2 is equal to 0, well, I'm going to get a positive 2 with what multiplicity? 5. There you go. So what's going to happen at both of these locations? If I were to look at the graph, is it actually crossing at the 2 and negative 2, or is it just hitting the axis at those locations and bouncing off? It's actually crossing. If it's an odd multiplicity, it's going to cross at this location. If it's even, that's when it bounces off. Questions on that? Is anybody not sure what I'm referring to? Okay. Well, we got one problem left, and then we're done with the notes for today. I know what you're thinking. We braved the cold and everything to come here. We want to do more math. We got to get back into it. See, Maya knows what I'm talking about. There you go. You'll turn around quick. Okay, so based on what we've talked about, try C. Okay, go ahead and factor that because both trinomials still need to be factored. Simplify, find me the roots, and then find me the degree. Oh, we didn't find the degree on B, did we? Okay, let me go back to this very quickly. So let's find the degree. Sorry about that. Well, there's no x with the 3, so we can ignore it. X squared minus 4, the power is 1, so that's just x squared. But x minus 2 to the 4th, if I expanded it, I'm going to get x to the what? The largest power would be 4. So this one, just like A, also has a degree of 6. All right. There we go. Now try C. It's about a minute and a half or so. And then when we're done with this, we'll have a good amount of time for you to look at your x. Yes. Oh, no, go ahead and factor it. Use that to find the roots. Okay. And then the degree will tell you each root's multiplicity. And then find me the degree for the entire expression. Okay, 2 minutes. I'll give you time. Okay, so this is what the two trinomials looked like completely factored. Okay, is that looking familiar? First one had a GCF before I broke apart the trinomial. So now you'll notice what repeats. Okay, we got the linear factor x minus 3. So when I write this out, I can say x minus 3 squared. I can go ahead and condense those. Then we have the x plus 2, and then we have the x minus 4. Okay. Once we've got it completely factored, we find our zeros. Starting with the first one, what does x equal? Yep, if I set this one equal to 0, there's nothing to simplify. I got immediately that x equals 0. Okay, so it's going to come into contact with the origin. With what multiplicity? 1. Okay. And then let's go to the second group. If x minus 3 equals 0, the next one is x equals 3. Multiplicity? Multiplicity 2. Okay, third, x plus 2 equals 0, x equals negative 2. Multiplicity? 1. And finally, x minus 4 equals 0, x equals 4 with a multiplicity of 1. Now, out of all 4 of those roots, okay, at which location would the graph not cross the axis? It would just hit the axis and bounce off. X equals 3. If the multiplicity is even, it won't cross at that location. Okay, we'll just have one point of intersection. If it's odd, it will cross. Okay. Now, we also need to go ahead and find the degree. Anybody tell me what they got? Harrison? We're close. It's not 4. 5. There we go. Because if I go ahead and use the same idea, and again, I can multiply this out if you want me to. Only one class has actually asked me to do that. But for this trinomial right here, the largest power I would get is x cubed. Because there's no power, there's nothing to expand. For this second one over here, the largest power is squared. So yes, we should have a degree of 5 on that particular polynomial. Okay. Like I said, if you want to multiply them out, if you want the extra practice for algebra skills, you're more than welcome to. I just don't think it's necessary. All right, questions. How are we doing? Pretty good. Okay. Well, we're going to go ahead and stop there. Let me go ahead and get this set up for the next class.